All right, guys, so 13.2 is almost exactly like what we did yesterday. It's just some more practice and maybe a few different types of problems will come up. So let's go ahead and start off by remembering that when we're doing these, we're solving, not just factoring. But to factor, it has to be in the form ax squared plus bx plus c. And that's pretty much the main challenge today, is it's got to be in that order, and we're going to have to get it that way. But we did some of these yesterday, so hopefully it won't be too bad. Now, in the first one, I have s squared equals 18s minus 81, and I talked about yesterday, we want our ax squared part, the s squared, to stay positive if we can. So I'm going to leave the s squared where it is, and I'm going to move the other stuff to the left side. So I'm going to do it in 2 steps. You could probably do it in 1. First thing I'm going to do is subtract 18s from both sides. Once I do that, since s squared and s can't combine, I have s squared minus 18s equals negative 81. Now I'm going to move the 81 to the other side also, so I add 81 to both sides. And I get s squared minus 18s plus 81 equals 0. Now we can use our swing method to factor it and then use that to solve. So the first thing is I have to factor it with the swing method is a trinomial. There's no GCF I can take out, so swing method's really my only option. My sum is negative 18, the b value, and my product is a times c, which is 1 times 81, which is 81. So if I start breaking down 81, 1 and 81 won't work. 2 won't go into 81. 3 will, 17 times. 4 won't. 5 definitely won't. 6 won't. 7 won't. 8 won't. But 9 will, with 9 and 9. Now 9 plus 9 is 18, but negative 9 times negative 9 is also 81 and negative 18. So there's our answer. So I need to break open my parentheses. I put my variable first, and we've got minus 9, minus 9. And remember, this all equals 0. Now, this is kind of a special case. This is one we're only going to get one answer for. Technically, you'll see 2, but it's really only one answer. If I set both of these equal to 0, you'll notice they're both the same thing. So if I add 9 to both sides, I get that s equals positive 9. And the other one would be exactly the same thing. So our answer is just 9. So that can happen. This would be like one of those kind of, when we were doing the area of square kind of problems where we got the same thing for both of our factors. Okay, so let's go ahead and go to number 2. Now, we have 16x squared equals 25. Now, again, we have to have everything on the same side, and if you notice, this has only got 2 terms. So let's move the 25 over. Let's keep the x squared positive. So I'm going to subtract 25 from both sides. I get 16x squared minus 25 equals 0. Now, this is not a trinomial. There's no GCF we can take out of it, so we only have one option for binomials, and that's going to be difference of squares. And if you notice, 16 is a perfect square, so is 25, so is x squared, and it's subtraction. So this one ends up being difference of squares. So to do difference of squares, we open up our parentheses. Remember, it's going to be equal to 0. Take the square root of 16 and you get 4, so we put that first. The square root of x squared is x, and we attach that to the 4. The square root of 25 is 5, so we put that in the end. One of them is positive, one of them is negative, and order does not matter. Now we can go ahead and solve. We have 4x plus 5 equals 0, and 4x minus 5 equals 0. So on the first one, I'm going to subtract 5 from both sides. I get 4x equals negative 5, and I divide by 4, and I get that one of my solutions is x equals negative 5 over 4. Remember, I want them in fractions, not in decimals. The next one's almost exactly the same, except I add 5 to start to both sides. I get 4x equals 5, and when I divide by 4, I get x equals 5/4. So there are your 2 solutions. When it's difference of squares, the solutions will always be opposite signs of each other. All right, let's move on to number 3. 8b squared plus 2b, or equals 2b plus 3. So this is kind of the same problem we had in the first one. we're going to have to move everything on over to one side to get the ax squared plus bx plus c. So I'm going to do this in one step this time. I'm going to go ahead and subtract 2b and subtract 3 from both sides. If you don't want to do it in 2 steps, feel free to do it in one, just like we did on the first one. So this gives me 8b squared minus 2b minus 3 equals 0. Now this is a trinomial. There's no GCF, so we can go ahead and try our swing method. So we need to find the sum, which is -2, and the product, which is -24. 8 times -3. So if we break apart 24, 1 and 24 is a factor, but that's not an option. 2 and 12 also, there's no combinations that will give us -2. 3 and 6, we're getting a little bit, I'm sorry, not 3 and 6, how about 3 and 8? We're getting a little bit close, but not quite. And then if we go to 4 and 6, well, that looks like an option. If I make the 6 negative, 4 plus -6 is -2. So there we go. So we open up our parentheses. I have b, looks like plus 4, b minus 6, and it could be in either order. You could have b minus 6, then b plus 4. But in this one, it's a little different from number 1 because our a value makes us have to divide, because in this one, a is 8. So I have to divide both of my terms by 8 and simplify. So 4 over 8 simplifies to 1/2. 6 over 8 simplifies to 3/4. Now that I've simplified my fractions, I can do the swing method. So I'm going to swing my denominator up front. I get 2b plus 1. And then I'm going to swing this denominator in the front as well. So I get 4b minus 3. And remember, that equals 0. So that's probably the hardest factoring one we've done so far, but it's still not that bad. It's what we've been doing. So now we take each piece, the 2b plus 1, we set that equal to 0. And we do the 4b minus 3 and set that equal to 0. So on the first one, if I subtract 1 from both sides, I get 2b equals -1. Then I divide both sides by 2. And one of my solutions is b equals -1/2. I go over to the other one. I need to add 3 to both sides. I get 4b equals +3. I divide both sides by 4, and I get my second solution is b equals 3/4. All right. Let's go ahead and go to the next page, number 4. I have 0 equals 24x squared minus 8x. It's a binomial. It's already on one side. It's already in the order, but if you notice, we don't really have a c value this time. So we have a binomial. It's obviously not difference of squares either, so maybe we should try some GCF. Remember, that's what we should generally try first. Well, 24 and 8, I can take a 4 out of both. That's the GCF. And since they both have an x value, I can take out an x to the lowest power, which is this x here, x to the first. So I take my 4x and I divide both terms by it. 24 divided by 4 gives me 6, and x squared divided by x gives me x. 8 divided by 4 is 2, and the x's cancel. So I have 4x times 6x minus 2. Now, there's no more squareds left. There's nothing else to factor, so we can go ahead and solve this one. All right, now, when I start looking at this, and I'm realizing this is kind of early in the morning, I still have 6 and 2 inside there, so I don't think I picked the right GCF. So I'm going to erase this real quick. I'm sorry, you guys. Because now that I look, 8 will go into 24 also, so my GCF is 8x. Now, if you'd done it with 4x, you would have still got the right answer, but this is just, another good practice for GCF. 24 divided by 8 gives me 3, x squared divided by x gives me x, and then 8x divided by 8x gives me -1, and that equals 0, okay? Either way you work it, though, you should get the exact same answers. And so you can see sometimes, yeah, there is another GCF even though you think you've got it. So let's set both of our terms equal to 0. So 8x equals 0. 3x minus 1 equals 0. When you have something times x that equals 0, just divide by it like you normally would. But no, 0 divided by anything gives you 0. So one of our solutions is 0. Over here, I need to add 1 to both sides. And I get 3x equals 1. When I divide by 3, I get my other solution, which is x equals 1/3. So be careful on the GCF, guys, and you should be fine. Let's go on to number 5. We're almost done. I have -2 equals 6n minus 20n squared. Now, I was telling you last time we want to try to get our n squared, our x squared part, positive. So I'm going to add it to the other side. Now, so I'm going to move both of those terms on the right to the left. I'm going to subtract 6n and add 20n squared. And I'm going to do that to both sides. So now I have 20n squared minus 6n minus 2 equals 0. So if you need to do that in 2 steps, go ahead, but just know we're moving them both to the other side. Now we have a trinomial, but we need to check GCF because those are kind of big numbers. And if I look, I have 26 and 2. I can definitely factor out a 2 through GCF first. 20 divided by 2 gives me 10n squared. -6 divided by 2 gives me -3n. And -2 divided by 2 gives me -1. And that equals 0. So now I need to go ahead and use the swing method on the trinomial that's inside our parentheses. So the sum would be -3, and the product would be 10 times -1 is -10. So 1 and 10 is our first one, but that's not going to work to get us -3. The next one and the last one is 2 and 5. Now that seems like a possibility. If I make the 5 negative, 2 plus -5 is -3. 2 times -5 is -10. So don't forget your 2 that we factored out earlier. I'm going to have n plus 2, n minus 5. But then I have to divide by my a value. And in this case, it looks like our a is 10. So I divide these by 10 and simplify. 2 over 10 simplifies to 1/5. And 5 over 10 simplifies to 1/2. Now I can do the swing. I'm going to bring my denominators to the front. So I have 2 times 5n plus 1 times 2n minus 1. And that all equals 0. Now you don't have to worry about the 2 when you're putting in your solutions. You need to worry about the other 2 factors, because if I put 2 equals 0, that's just kind of confusing. So I have 5n plus 1 equals 0. And I have 2n minus 1 equals 0. So let's just solve these. I subtract 1 from both sides. I get 5n equals -1. And when I divide both sides by 5, I get my first solution, which is n equals -1/5. Now we go and solve the other one. I add 1 to both sides. I get 2n equals 1. I divide both sides by 2. I get n equals 1/2. All right. Let's go on to the last one. Number 6 is 12r squared minus 3 equals 0. So everything's on the correct side. Our r squared is positive. So it doesn't look like that's difference of squares, so I can't do that yet. It's not a trinomial. So let's make sure we can't take a GCF. I have 12 and 3. Well, the GCF of 12 and 3 is 3. I can't take out an r because both terms don't have an r. So I'm going to divide both terms just by 3. 12 divided by 3 gives me 4 with the r squared. 3 divided by 3 gives me 1. And that all equals 0. Now, once I've done that, I look inside the parentheses, and it looks like I might have difference of squares. 4 is a perfect square, so is 1. I have r squared and its subtraction. So I'm going to remember my 3. I'm going to open up my parentheses. The square root of 4 is 2, and the square root of r squared is r. So 2r goes in the front of both. The square root of 1 is 1. Make one of them minus, one of them plus. Now we can set our factors equal to 0, just like we did in the last one. I have 2r minus 1 equals 0, and 2r plus 1 equals 0. I add 1 to both sides on the first one. I get 2r equals 1. I divide both sides by 2, and one of our solutions is 1/2. I subtract 1 from both sides in the other one. I get 2r equals -1. I divide both sides by 2, and I get our second answer, which is r equals -1/2. So not a whole lot different from yesterday. You do need to watch out for GCF and difference of squares today, whereas you didn't have to yesterday. If you have any questions, just let me know, and good luck.